This conference will now be recorded.
So today we'll try to understand what is Docker, what is Docker, and why do we need Docker. We'll try to discuss about the Docker and why people are using Docker. So you may have a question, sir. We are already done all the things. We are already able to build the application using build tools. We are already able to deploy those applications using CI/CD tools like Jenkins. We already know what is infrastructure, what is server, what is storage, what is load balancer. We already are able to deploy that applications, whatever applications we wanted to deploy, we are already able to deploy. Then what is this Docker? Why do we need Docker? And what is Kubernetes? Why do we need these Dockers and Kubernetes? Wherever we go, people started talking about the Dockers and Kubernetes. Without Docker and Kubernetes, did we already able to deploy the applications? So far, we deployed a lot of applications. We are able to access those applications also. We deployed already a lot of applications, right? So last week also we deployed and accessed that applications. So then what is this Docker? How different it is? The way we have deployed so far. We'll try to understand. So just as a definition, if you see what is Docker? Docker is a, as a definition, if you see, Docker is a containerization platform or containerization platform or software using Docker we can build and we can ship and run applications as containers. So Docker is a containerization platform. Docker is a containerization software. Using Docker, we can build, we can ship, we can run our applications as a containers. So before we discuss about what is container, why do we need to create and deploy applications as a container, we'll try to understand the past and present deployment approaches. So the past and present deployment approaches. Before we get into a Docker, today I am not actually getting into a Docker. Today we'll try to discuss why we need a Docker, how we used to deploy before Docker. As you guys already know, did you guys use Docker or any Docker Swarm or Kubernetes kind of a softwares anywhere as of now to deploy the applications? No. But are you guys able to deploy the applications, build and deploy the applications? Yes. So before Docker, how we used to do? With the Docker, how we can do? We'll try to discuss today. But before I get into actual Docker and Kubernetes is very, very important. It's like not us. Very, very important nowadays. If you go to any projects, either they might be using Docker with a Docker Swarm, that is less, but most of the projects will be using Docker with Kubernetes. This is widely used combination. Docker with Kubernetes is widely used combination. So this Docker and Kubernetes is very, very important. As a DevOps engineer, if you wanted to become a DevOps engineer, these two are like a mandatory tools to know. Sir, will I able to get a job without Dockers and Kubernetes? Will I able to get an opportunity as a DevOps engineer without Dockers and Kubernetes? Yes, you will get an opportunity, but the chances are very less. The chances are very less. Why the chances are very less? Because everyone is expecting the people should know the Docker and Kubernetes. So let's say if you have a Docker and Kubernetes knowledge, the chances of getting a job is more. You have maybe you will get a 10 calls or 15 calls if you showcase that you have experience or you have knowledge on Docker and Kubernetes. Let's say you have done, you have not mentioned you have experience or you have not mentioned Dockers and Kubernetes in your resume. The recruiters may not prefer. The chances of getting calls will be less. Maybe hardly you will get 2 or 3 calls. So these are very, very important. At the same time, this is very, very complex subject also compared to others. Whatever you learned so far is one thing. These two are is different thing. It is little bit complex, but I can say it again. It is not a rocket science. You are not doing anything. You are not launching on your own anything. It is complex, but if you spend some time, sir, where is the time? First of all, I don't have time to attend the classes also. People are not at all attending. So that is different story. It's up to them because they are not attending. I can't do anything with them. But even though you are attending, not just attendance, since the sake of Balaji, for the sake of Bhaskar, you should not attend like that because we are scolding. So don't attend like that. Even though you are attending, well and good, but at the same time you need to put lot of effort. Go through this recording multiple times. If you are not able to understand one time what is Docker, what is Kubernetes, go through this recording one time. If you are a quick learner, if you are a slow learner, go through the recording one more time, right? So that you can easily understand. At the same time, practice. Practice is very, very important. At the same time, practice is also very, very important. But that need a effort, that need a commitment. Yes, I need a job. At any cost, I need a job. Yes, I need to learn these tools to improve my opportunities. If you have that commitment, that zeal and focus, nothing is impossible. But if you like a kind of a give up guy, you are attending one class, Bhaskar sir, Balaji sir is teaching some Chinese language, I don't know. If you have that mindset, if you drop, will you able to get into this opportunities? No. Even though you don't understand one time, try to understand one more time. Try to understand one more time. Go through the recordings. That's why we are sharing the recordings. People are using like they're not attending the classes, they're just going through the recordings. That is different story. So why I'm stretching this much again? Because these are mandatory tools, guys. If you have these tools in your CV, the opportunities, the opportunities, the packages also will be very good if you know these tools along with whatever tools you learn. Each and every topic, as I already told, each and every session is related to other session. Again, if you are not regular student, you are attending today, you are not attending tomorrow, and again you are coming in the next class, you cannot understand again. Each and every topic is related to other topic. Without knowing Docker, will you able to understand what is Kubernetes? No. Within Docker also, if you don't know one topic, will you able to understand other topic? No. It is like you are learning ABC and you are skipping XYZ like that. So everything is important. Most of them are interrelated. Most of them are related to each other. So I request everyone to attend each and every session. Even though you miss 1 or 2 sessions, I understand there might be personal emergencies. There might be some health issues. Fine. At least go through the recording before you come to the next classes. Once you recover, once you recover, go through the recordings and up to date, then you can continue. So this is very, very important. Each and every topic is important here. Try to focus here. So let's continue. I am requesting for whoever is there in the class. I already left, people who are not attending. I already left. I can't do anything for them. Now, with that background, let's try to understand what is Docker. So we'll discuss all these things. I no need to go through this one, what we are going to cover. We are going to cover more than whatever I have documented here. First, let's understand the past and present of deployment approaches. The past and present of application deployment approaches. How we used to deploy applications in the past and how we are deploying the applications in the present. So past, let's take early 90s or early 80s. Let's consider in early 1990. Let's consider in early 1990 how we used to deploy the application. The typical traditional deployment model. Typical traditional deployment model to deploy any application, whether it's old or latest. What is the important thing? Do we need a hardware? We discussed already this one when we are discussing about AWS also. We need a hardware, but in early 90s, I mean to say till 2000 also, we used to follow this traditional deployment model. We have a hardware. On top of that hardware, we have an operating system. This we call it as a physical machine, physical machine, physical servers. So we have a hardware in that physical machine. In that physical machine, we used to have some operating system that can be Linux, that can be Windows, that can be any operating system. On top of that operating system, we are trying to have that application code and whatever required softwares to deploy that application and its libraries in the traditional deployment model. In the traditional deployment model, we had a physical machine, the physical server, in which we have some operating system, and we are going to deploy that application, right? So this is my application code. Without this one, will I able to run my application? Without this one, will I able to run my application? No. So this is my application code. Let's say this is one of the Java based var file. This is one of the Java based web application. This is my application code var file. Can I deploy this application? Can I deploy this var file without required softwares, libraries, and configurations in this machine? Not possible. So in early 90s, we used to deploy like this. What is the problem with this traditional deployment model? Why people started using different concept called virtualization or virtualized deployment? Virtualized deployment. So when it is traditional deployment model, I have a physical hardware. Let's consider this physical hardware. This physical machine, I have my system with, let's say, 128 GB capacity, 128 GB RAM, let's say, and I have 32 core processor. I have 32 core processor, let's say, just to give an example. Now 128 GB RAM I have, and let's say 32 core CPU processor I have in this physical machine. This is the capacity of my server. So I am trying to deploy one application. Does this application requires this much resources to run? Does this application require this much resources, this much CPU, this much memory to run this application? Not required. So this application This application might be hardly using 4 GB. Just to give an example, I am taking this application might be using 4 GB RAM, maybe 2 core CPU, or 8 GB RAM, 2 core CPU. This application might be using the 4 GB RAM or 2 core CPU to run that application. And also maybe OS, maybe operating system. Does operating system also require some CPU and memory to boot and work? Yes. Maybe operating system, let's say operating system is taking maybe again something like this. Just to give an example, I am taking this much. Maybe it is taking 2 GB RAM, the OS process, and 1 core CPU, just to give an example. So this much resources are used, but do we have lot of resources, lot of hardware resources underutilized here in this traditional deployment model? Hardly I am using 10% of my capacity. Hardly we are using 10% of my capacity. Hardly we are using 10 GB RAM out of this capacity. But you may have a question, sir, why can't I deploy a lot of applications in the same physical machines? Can't I deploy 10 applications, 20 applications in the same server? You may have a question, why only one application? Can't I deploy multiple applications in the same server? Why can't we deploy? Any guess, any idea why? Why can't we deploy a lot of applications in the same server? Not only server crash, not only server crash, it is not nothing to do with server crash. Isolation. You need to isolate, you need to isolate one application from other application. Isolation. What is the meaning of isolation? Let's say I deployed two Java applications. Now, let's say it is using same JVM process. Let's say I have installed Java 1.7. Let's say it is using same JVM process. I deployed two applications, Java applications. JVM, same Java process for both application. One application is causing issue in the JVM. Does other application also will impact? Does other application also impact? It is like a virus, right? You are already infected. You are already infected. Do you need to isolate from others so that others will not get infected? So similarly here, if I deploy multiple applications, for all these applications, is storage common? Is the network common? Is the process area common? Storage is common. I mean to say server storage is common. Process area is common. User space is common. Network space is common. So if one application is having issue, will it impact other applications since it is sharing same storage space, network space, process space? Yes. So even though you have enough resources, even though you have enough resources, is it recommended to deploy multiple applications in the same server? No. You need to isolate one application from others. You need to isolate one application from others. That's why it is not recommended here. If I want to deploy, if I want to isolate, I need additional physical machines. But I already have a lot of resources. Are we wasting resources here? Yes. So to overcome this challenge, people started different approach in early 2000. People started using different approaches in early 2000. Virtualization. Virtualization came into picture. Virtualization era. It's very major move in IT industry, this virtualization concept. So this virtualization came into picture in early 2000. So what is this virtualization? Is virtualization and cloud are both same? people might be still confused between virtualization and cloud. Is virtualization and cloud both are same? No. But in cloud, people are using virtualization concept. In the cloud, like AWS, does people are using virtualization concept? Yes. Cloud is different, virtualization is different. Can I do the virtualization in on-prem servers also instead of cloud if required? Yes. So what is virtualization? So we have a hardware. We have a hardware. This hardware, we can call it as a physical machine, physical boxes. If you remember, I have shown when I was discussing about AWS, I have shown the images how that physical servers looks like. This is hardware, the physical servers, the physical machines. On top of these physical machines, using hypervisor, will I able to isolate my hardware? Will I able to isolate my hardware resources? Yes. So on top of this physical machine, will I able to create multiple virtual machines using this hypervisor? Yes. On top of this hardware, using hypervisors, we can create a multiple virtual machines. Let's say this is my hardware, this is my physical machine. Same, let's say 128 GB capacity. 128 GB capacity. Now, 128 GB RAM and let's say 32 core processor. Just to give an example, I am taking. This can be anything. It can be 16 GB, 32 GB also. Now, instead of directly deploying my application like this, here, what I am trying to do here, what we are trying to do here on top of this hardware using hypervisor, what we are trying to do, we are creating a virtual machine. This is one virtual machine. This is one virtual machine. So while creating a virtual machine, can I allocate resources, hardware resources for this virtual machine? From this hardware, can I create a hardware resources for this virtual machine? Yes. So while creating virtual machine, this virtual machine, based on my requirement, can I create a virtual machine with 16 GB RAM and maybe 4 core processor based on my requirement? On top of this hardware, I can create a virtual machine like this. And we still have resources in this hardware. Can I create a one more virtual machine? Can I create a one more virtual machine based on your requirement like 32 GB RAM, maybe 4 core processor or 8 core processor like this? Yes. In this virtual machine, again I will have an operating system. This operating system, we will call it as a guest operating system. So in each virtual machine, do we have a separate operating system? In each virtual machine, do we have a separate operating system? Yes. In each virtual machine, you have a separate operating system. So in this virtual machine, can I install one application with the required softwares and libraries? Yes. And in another virtual machine, can I install another application with required softwares and libraries for that application? Yes. So since this is separate OS, is the process area, user space, process space, network space is common between these two? No. It will have its own user area, process area, network area. This will have its own storage area, user area, process area, network area. Because this is separate OS, this is separate OS. If something goes wrong with this application, which is running in this virtual machine, something is impacted in this application, which is running in this virtual machine, will it impact this application, which is running in a separate virtual machine? No. So this way, are we isolating applications from others using this virtualization concept? At the same time, am I able to utilize my hardware resources more efficiently? If required, you still have enough space, enough hardware. Can I create multiple virtual machine like this on top of this hardware? If I still have enough resources, can I create a multiple virtual machines like this? Yes. But what is common for all these virtual machines? What is common for all these virtual machines? The underlying hardware. What is hardware? What is hardware? Your CPU, your memory, hardware. Here, with the help of hypervisor, what we are trying to isolate? We are virtualizing what? We are virtualizing our hardware resources. We are virtualizing our hardware resources using this hypervisor. There are two types of hypervisors here. Again, there are two types of hypervisors here. Type 1 hypervisor and type 2 hypervisors. Type 2 hypervisors and type 1 hypervisor. So what is type 1? What is type 2? Anyone has any idea? If you are from virtualization background, if you are from VMware background? Any answer is opened. Whatever you know. If you are already know, you can just answer. Otherwise, I'll discuss in some time also. So this type 1 hypervisor, we call it as a bare metal hypervisor or native hypervisor also. We call it as a bare metal hypervisor or bare metal hypervisor or native hypervisor. If it is a type 1 hypervisor, if it is a type 1 hypervisor, do I need an operating system on top of that hardware? If it is a type 1 hypervisor, do I need this operating system on top of that hardware? Not required. Not required. If it is a type 1 hypervisor, I don't need this operating system. Does hypervisor will work directly on top of hardware without this operating system also? This operating system also, will it work directly on top of that hardware? If it is a type 1 hypervisor, yes. You don't need this operating system. So that is type 1 hypervisor. So what are the examples of this type 1 hypervisors, right? You have ESXi, we have VMware ESXi boxes, we have Oracle VM servers, we have Zen XCP, like this. So type 1 hypervisor is bare metal hypervisor like VMware ESXi boxes. VMware ESX or ESXi. Citrix Zen. This one is type 1 hypervisor. And also like this we have Dell XCP. Like this we have some type 1 hypervisors. So do I need to have any operating system on the top of that hardware to create a virtual machine? Not required. So if it is a type 1 hypervisor, can I directly create a VMs on top of that hardware? That hardware comes with type 1 hypervisor. That hardware itself comes with type 1 hypervisor. So do I need any operating system to be created, system to be installed, operating system to be installed to create these virtual machines on the type 1 hypervisor? No, not required. we can directly create a virtual machines. If it is a type 2 hypervisor, it is a software hypervisor. Examples for type 2, you guys might be already using type 2 hypervisors like Oracle VirtualBox. This is one software. In your laptop also, will you able to install this Oracle VirtualBox and create a virtual machines within your laptop also? If you have a 16 GB RAM, 16 GB RAM and 8 core processor in your laptop or desktop, you already have a laptop with Windows operating system. Let's say you already have a laptop or desktop with Windows operating system. Using this Oracle VirtualBox within your laptop or desktop, can I create virtual machines on top of your laptop or desktop? Yes. Oracle VirtualBox, VMware Workstation, VMware Workstation, and Hyper-V. In our Windows laptop also, do we have some some software called Hyper-V? Using that Hyper-V, if I enable the Hyper-V, can I create a virtual machines in our Windows laptop also? Yes. So these are type 2. But this type 2, does it require some operating system first on top of that hardware? Yes. But in actual data centers, or whether you are using cloud, what type of hypervisors they will be using in the cloud or in your own data centers? Type 1. So I think I already told AWS. Is using what hypervisor as of now? Citrix Zen. So whatever EC2 instances we created, is it a virtual machine on top of that hardware they have in their data center? So they have a physical boxes, that hardware. So they have a hardware. This is type 1 hypervisor. The hardware comes with the type 1 hypervisor. You are creating EC2, but in the background, is it a virtual machine on top of the hardware which is owned by AWS, which is placed in the AWS data centers? That EC2 is nothing but one virtual machine on top of the hardware which is bought, maintained, managed by AWS in their own AWS data centers. That EC2 is nothing but a virtual machine. Now, in this virtualized deployment, can I create a virtual machines on top of this hardware using hypervisors and deploy my applications, and each virtual machine is isolated from others? But what is common for all these virtual machines? The underlying hardware, the underlying infrastructure, not OS, guys. This OS, it is not OS. Still someone is saying OS. This is, as I already told, in actual data centers, whether your own data center or cloud, what hypervisors will be used? No one will use type 2 hypervisors in the actual data centers and the cloud. Type 2 is only for like a local, in your local laptop or server. Only type 1 in data centers or cloud. So there is no OS here. If it is a type 1. So what is common for all the virtual machines which is running on top of this physical machine? The hardware. Only hardware is common. But if there is any failure in the hardware, will it impact all these virtual machines again, which is running on top of that one? Yes. If there is any failure in this hardware, these all virtual machines will be impacted. But there is no issue with hardware. There is issue with some software or OS or software. If there is issue with this OS or software, will it impact other application, other software or other operating system which is running in a different VM? No. Now, let's say I deployed one application here, I deployed another application here. Whenever there is a change in this application, do I need to stop this application? Do I need to delete or stop this application? Not required, right? This is already isolated. I can only do the required changes in this machine. But if it is common, let's say I deployed multiple applications in same server. Let's say I have deployed 3 WAR files under same Tomcat. 3 applications, 3 WAR files under same Tomcat. Now, whenever there is a change in this application, if I stop the Tomcat, does other 2 applications also will impact because you stop the Tomcat, right? And you are doing the deployment. So not only that purpose, let's say one application is causing issue in the JVM or in the operating system. One application, one process is causing the issue in the JVM software or in the operating system. Does other applications also get impacted because of impact in the common area? Yes. So that's why it is not recommended to deploy. That's why it is not recommended to deploy multiple applications in a same this way. To overcome this one, people started using virtualization. It's a very big revolution in IT industry. VMware, that VMware company, as a VMware company, they had done this one, and it's very big revolution in IT industry. In early 2000, people started using this virtualization concept. Now again, later in early 2000, it's very big revolution. If you remember, if you are learning some VMware courses, you are like kind of a hot cakes in early 2000, 2002, 2003, 2005, 10 till 2010. It's like a very good demand. VMware administrators, VMware admins with very high salaries. But now, again, not same trend, right? Again, technology will keep evolves. Now, from early 2012 or 13, from early 2012 or 13, again different process, again trend changed, not to the cloud, not to the cloud, not to the cloud, to the containers, to the containers. Containers, cloud came almost in 2010. Also a lot of people started using cloud. People are still using cloud, whether cloud or data center. The new trend came here. So people started following container deployments. Container deployments. So what is the problem with this virtualized deployment or virtual machines? Why people started using container deployment? Dada Saheb is still asking what is the use of this OS on top of hardware. I already told this is not mandatory if it is a type 1. In your local laptop, does your local laptop is a type 1 physical machine? Your local desktop which you are giving, physical machine is different, laptop and desktop is different. Physical machine is, it's kind of a this box. This is kind of a this box. That is not exactly like your laptop or desktop. It will be something like this. It's very big box. Uh, Let me show you. So, physical servers. This is how it looks like. This is how it looks like. It is not like your laptop or desktop. This I can call it as a physical server or physical box. Physical server or physical box. So this comes with type 1. Type 1 hypervisor. Do I need to install operating systems to create a virtual machine within these physical machines? Do I need an operating system to create a virtual machines within this physical machine on top of this physical machine? Not required. So This is not at all required. I already told. When this is not at all required, if it is a type 1. This, if it is a type 2, do I need operating system? Without operating system, can I use type 2 hypervisor? No. So suppose you have a laptop. You have a laptop. Let's say your laptop has Windows machine. Your laptop has 16 GB capacity. If required, can I create a virtual machines in my laptop also? If required, can I create a virtual machines in my laptop also? Yes. But if you want to create a virtual machines in your laptop, what type of hypervisors has to be used? Type 2. So do you already have an operating system in your laptop or desktop? Do you already have an operating system in your laptop or desktop? Yes. On top of this one, can I install type 2 hypervisor like Oracle VirtualBox? We can use Oracle VirtualBox, you can use VMware Workstation software, or you can use Hyper-V. So type 1 hypervisors we are going to install as a DevOps engineer. That is not our job, guys. So that type 1 hypervisors comes with the hardware itself, but even though that is not our job. So there is a data center admins who is responsible for fixing those physical boxes in the data centers. They are in the field. They are in the field. I mean to say the field engineers. We call it as a field engineers or data center admins or engineers. So they will get those boxes and manage in the data center. That is not our job. Okay. But how it works is very important. Now, what is the problem with this virtualized deployment? Why people started using containerized deployment? Any guess? By looking at this diagram, any guess? It is nothing to do with auto scaling. It is nothing to do with auto scaling here. What is the problem with virtualized deployment? What is the problem? What is why people started using containerized deployment? If you see here, does each virtual machine has its own operating system? So do we need to manage lot of operating systems if I use virtualization concept here? Each virtual machine has a full-blown operating system. One thing. Does each OS will take again lot of CPU and memory because it's full-blown operating system? Does each OS in that VMs will take lot of CPU and memory? Yes. Virtual machines are heavyweight. Virtual machines are heavyweight. What is the meaning of heavyweight? Will it take lot of time to configure, and will it take lot of time to boot? Will it take lot of CPU and memory? Yes. Here, one more problem here. Now I deployed this application in this virtual machine. Will I able to easily port? Will I able to easily port this application from one server to other server? Will I able to easily move or deploy this application from one server to other server if I am using virtualized deployment? If you understand? No. What does it mean? What does it mean? Let me tell you. Now I have this virtual machine. Let's take whether it's a data center, whether it's a cloud, that doesn't matter. Everyone using same concept, virtualization. Now, let's say I deployed one application here. This is one of the server. This is one of the virtual machine. In this virtual machine, let's say I have some operating system. I have some operating system. We call this as a guest operating system. Now, on top of this operating system, without doing this step, without doing this step, without doing the software's configurations and libraries? Will I able to deploy my app here? No, I cannot run this here. Now let's say same application I want to deploy in a different server. Now let's say I have a different server, maybe in different hardware, that doesn't matter for me here. If I have a virtual machine there, it has some operating system, and while doing this step, without doing this step, will I able to do this without having those softwares and libraries deployed? Will I able to deploy this application? One thing, will I able to deploy this application in this server without doing this? No, this has to be done. But at the same time, even though application code is same, application code is same, sometimes that application may work here, sometimes that application may not work here. What could be the reason? Application works in one environment or one server, it may not work in another environment or another server. What could be the possibilities in this case? It's nothing to do with hardware. Hardware is just a CPU and memory, right? It's nothing to do with hardware. Hardware is just a CPU, processor. It's just a motherboard, RAM, nothing else is there, right? It is nothing to do with hardware. It's issue with this piece. It's issue with this piece. Softwares and dependencies. Let's say when you are configuring this machine, virtual machine, you have wrongly installed a different version of the softwares, or you missed to set some configurations, or you missed to set some environment variables in this server, but you have properly done the configurations or properly installed required softwares, dependencies, configurations, or environments properly done here, and you have missed to do something here. Even though application is same, will it work here? Dependencies, application dependencies and configurations are not compatible, then it may be a problem. This is one more challenge. Now another challenge is the virtual machines are heavyweight, which means is each virtual machine is having its own operating system, full blown operating system, lot of OS. Dependency examples. Now let's say I want to deploy one WAR file. There are two types of dependencies: application dependencies, software dependencies. Application dependencies and software dependencies. So application dependencies, like your Maven dependencies. If it is Java based application, Maven dependencies. If it is Node.js application, your NPM dependencies, libraries, application dependent libraries. That comes with WAR file itself. If it is a Java based application. Is your application dependencies, will it be part of your jar, var, whatever it is, if it is Java based application? Yes. And software dependencies. What is the meaning of software dependencies? Configurations. Here I am talking about. To run this one, do I need to have some softwares like Java, Tomcat here? Maybe this application is developed using some features which is Java 1.7 features. Let's say Java 1.7 features people used and deployed that application. But here you guys installed Java 1.5, but you are using Java 1.7 features in this code. Again, will it work? No. Let's say compatibility problems. Now, one more, configurations. What is the meaning of configurations and environments? Let's say you are doing some changes in the, you are tuning Tomcat software. Maybe in the server.xml, you are modifying something. Can I call that as a configuration? You are modifying something in the server.xml, you are modifying something in the Tomcat users.xml. That configuration, that software configurations, you might have done that here, but you missed to do that here. Again, you will have issues. I'm just giving as an example, guys. I'm just giving as an example. Configurations. Can I call those as a configurations? What I'm trying to do that? Yes. Configurations and environment variables, like environment. You are setting some environment variables in this server, and you are not setting those environment variables in this server, and those environment variables are used by your application. Again, will it work? Your application using some environment variables, and you are not setting those environment variables. Again, will it work as expected? No. So because of these compatibility issues, dependencies, software dependency or application dependency or configurations or environments, whatever it is. So same application might be working in one server, other application might not be working in, same application might not be working in other server. If you are from a development background, or if you are from QA background, this is common, right? QA comes to you as a, you are working as a developer, the QA team will come to you, hey man, this application is not working in QA environment, it is working in local environment. As a developer, our mentality, what you say, I don't know, madam, it is working fine in my local laptop. I deployed locally in my local laptop, it is working fine in my local laptop also. I deployed in dev also it is working fine, but I don't know why it is not working in QA environment or prod environment. What could be the possibilities in these cases? The compatibility issues, that can be software compatibility, that can be operating system compatibility, that can be configuration mismatch, that can be environment mismatch. This is going to happen. This is going to happen that way. And also lot of overhead for operating system. Will I able to quickly deploy these applications in a virtualized deployment? Does it take time to create a VM? Does it take time to configure that VM? And does it take time to deploy this VM? It's heavyweight. This is one more challenge. And also one more thing which I wanted to cover here. Suppose I have created a VM like this. This VM I created with 4 GB RAM and 2 core processor. One more VM I created like this, 8 GB RAM, just to give an example. One more VM I created with 8 GB RAM, let's say, and 4 core processor on top of this hardware. Let's say I deploy different application here. This application is not taking that much CPU and memory. The OS along with application is not taking this much memory. I have some memory still available. Let's say, just to give an example, 2 GB memory is still available. But this application which is running in this server is running out of CPU and memory. Is this resources can be shared between these virtual machines even though they are running in same machine? This has enough memory. This doesn't have enough memory. It cannot be shared. If you want to share, what needs to be done? You need to stop this VM. You need to stop this VM, reduce the capacity of this VM, and increase the capacity of this VM. Stop this VM, again increase the capacity of this VM. But is the hardware resources, I mean to say, is the CPU and memory can be shared between these two virtual machines? CPU and memory can be shared between these two virtual machines? No. So we have some challenges. We have some challenges with virtualized deployment. That is where containerization came into picture. Guys, whatever I am explaining today, if you understand and if you follow this one, learning containers, learning Docker and Kubernetes is very easy. Why containers? What is the problem with this traditional deployment, physical deployment approach we discussed? What is the problem with virtualized deployment we are discussing? So that you can easily understand why containers and how to use containers. Now, to overcome this one, people started using different concept called containerization. People started using a different concept called containerization to overcome all these challenges. So what is containerization in general? In general, first, what is container? Forget about containerization. In general, what is container, guys? In general English, in plain English, what is the meaning of container? Container contains something. Can I carry something? Can I carry something using container? In our daily life also we will use containers. In our daily life also we will use containers, right? Your tiffin box is one container. Using your tiffin box, right? That is kind of one container. Are you able to carry your food from one place to another place easily? Yes. And also, like whenever you are shifting your home, you will hire some container to move your all the things. You will neatly pack all your belongings. You will neatly pack into that container so that it will be easy for moving from one place to another place. Similarly, in the software also we can use container concept. Everything started in software with small ideas. So in software also we'll use same concept of containers to carry. So in application container, I'm talking about application container now. So application container, using this container, application container, can I carry my application along with its required dependencies and software's configurations, environments? Just to make it simple, if I have some way to carry this one from one place to another place, if I have some way to carry this application code plus the softwares and libraries, we no need to worry about the hardware. You no need to worry about the hardware. You just need a motherboard, CPU, memory, storage. That can be any hardware. You no need to worry about hardware. You no need to worry about operating system also. I'll tell you in some time. If there is some way to carry this one from one place to another place, will I able to quickly build and deploy the applications? That is what happening using containers. So container, in IT terminology, what is container? Container contains everything which is required to run a piece of software. Software is nothing but application. Software is nothing but application. Container contains everything which is required to run a piece of software, a piece of application. Now, everything, what is the meaning of everything? Like, it contains application code plus application code plus required softwares. It's a dependencies. What is the meaning of its dependencies? As I already told, it's a dependencies. Required softwares plus libraries, comma, configurations, comma, environment, etc. So container contains everything which is required to run a piece of software. It contains application code and its dependencies, configurations, and environment. Now, instead of deploying my application directly on this virtual machine, I can bring one more concept here. If you see, let's say here, same hardware, and I have an operating system. So this one, guys, this one can be this virtual machine also. This virtual machine also. Whatever I have highlighted here, this can be achieved here itself. This can be achieved here itself. Instead of directly deploying my application on the server, I can deploy my application as a container. But what tool I have to use? Do I need to use some tool to create a containers and manage the containers? The way we are using hypervisor to create a virtual machines, manage the virtual machines, do I need to use some software to create and manage the containers? Yes. So that is where the Docker comes into picture. So using this containerization, what we are doing, let me tell you. I have one machine. I have one machine. This machine can be a physical machine or virtual machine. Again, whatever I have here, right? This one, this can be a physical machine or virtual machine. But instead of deploying my application directly like this, am I deploying directly my application like this if I am using containerization here? Am I deploying directly on top of the OS like this? If I am using containerization? If I am using containerization, do you see some additional layer here, guys? Do you see some additional layer here? Are you directly deploying the way you are deploying in the virtual machine in the virtualized deployment? No. Do you have a one more layer here? That containerization. So here, let's take this to make you better understanding. Now I have some machine like this. Instead of directly deploying my application like this in this machine, I can use one concept called containerization here. I can use one concept called containerization here. I will not deploy like this. On top of the operating system, I will not directly deploy like this. Now, we are going to use one more concept called containerization here. Containerization. Containerization software. So Docker is one of the containerization. It is not one and only containerization software, just it is one of the containerization software. Using that containerization software, will I able to isolate operating system itself? OS level will I able to isolate? Will I able to isolate the applications within OS level also using this containerization? Yes. So using this containerization, what I can do, can I deploy this one as one container? Can I deploy this one as one container? Which means on top of this containerization, can I have something like this? This is one container. This is one container and its related softwares and libraries. Similarly, can I create a one more container in the same machine? In the same machine, can I create a one more container in the same machine? That can be physical machine, that can be virtual machine. Can I create a one more container like this in the same machine? Yes. In the same machine, I can create a one more container. Does containers have like operating systems? Does container will have a full-blown operating system? Does each container will have its own operating system? No. Containers will not have a full-blown operating system. So can I call containers as lightweight here? Yes. Containers are lightweight. Just to make it simple, using containers, instead of deploying applications in two different virtual machines, Instead of deploying these two applications in two different virtual machines on top of two different operating systems, in single machine using containerization, will I able to run the same two applications in a single server using this containers concept? Yes. Guys, instead of having like this two separate virtual machines to run two different applications, can I have a single server? Within single server, can I isolate applications again using this containerization concepts by deploying my applications as a containers? Yes. So on top of this operating system, am I directly running this application process? On top of this operating system, am I directly running the way I am running here? No. Are we using something called containerization here, container software here? Yes. So using this containerization software, I can run these containers like this, like this. In same machine, can I deploy multiple applications like this in same machine? As a containers? Yes. And is each container is isolated from other? Which means does each container will have its process area? Will it have its own network area, storage area? Yes. Sir, how come that is possible? Because for all the containers, what is common? For all these containers, what is common? The OS also common, the host operating system. But how this is possible? These containers basically is going to use some features available in the kernel. Some features available in the kernel. We will discuss that in some time. Each container is isolated. Each container is isolated from each other, which means if something goes wrong with this container, this is one container, this is another container. If something goes wrong with this container, which means if something goes wrong with this application or this software or library, if something goes wrong with this container, will it impact the other container even though they are running in a same machine? No. But what is common for all these containers which is running in this machine? What is common? Operating system. Let's forget about containers sometime. Suppose if I don't have a containerization software, how many virtual machines I need to deploy these three applications? Forget about containers. Let's say how many virtual machines we need to deploy these applications? Three virtual machines. Does each virtual machine has full operating system, full blown operating system again if it is a virtual machine deployment? Yes. Now, if I am using containerization within single virtual machine also, within single virtual machine also will I able to deploy these many applications using containers? So in that case, do I need a three different operating systems? Do I need to have a three systems with the three different operating systems? No. So containers are lightweight. Containers are lightweight. How can how I can say it is lightweight? Are you going to weight these containers? No. So how I am saying these containers are lightweight, because does each and every container will have its own operating system, guys? No. So what is common for all these containers which is running in same machine? This host operating system. This host operating system. So do we need lot of CPU and memory here? Because this will not have an operating system. This will not have an operating system. This will not have an operating system. So are we wasting our resources to run multiple operating systems here? We are not wasting our resources to run multiple operating systems here. Same operating system, multiple containers. Now, operating system is common for all these containers. And at the same time, is it going to use the underlying system resources? Is it going to use underlying hardware resources like CPU, the system resources, that virtual machine resources or physical machine resources, whatever it is? Is it going to be used the CPU and memory? from that underlying system. This container, this container, this container can use the underlying system resources like CPU and memory. Now let's say this system has 32 GB. That can be a virtual machine or physical machine. Now this container might be taking 1 GB, this container might be taking 2 GB, this container might be taking 4 GB, like that. If there is a lot of load on this application, will it able to take the resources available from the system? Still some resources available based on the load. Will it able to go to 5 GB, 6 GB also memory? Can this process can use 5 GB, 6 GB also if required? Yes. So is system resources also common for all the applications or all the containers which are running in that machine? System resources is also common, and also host operating system is common. So this way, can I call these containers are lightweight because containers doesn't require lot of CPU, lot of memory? Now, how these containers are isolated from each other? You are running in a same server, but how it is isolated? So for all the containers, for all the containers which is running in same server, same machine, what is common? As per this diagram, what is common? You can understand. Host machine kernel. Host machine kernel. So the containers will not have a guest operating system. The containers will not have an operating system. It will share host OS. What is the meaning of host OS here? What is the meaning of host OS here? Host is nothing but the server in which you have these containers. Can I call this server as a host for these containers because you are hosting these containers in this server? So can I call this operating system as a host operating system where you are hosting your containers? Yes, it's common for all the containers. So it is going to use host system kernel. Host system kernel. Sir, what is this kernel? If you are from engineering background, if you are from BTech background, you can understand kernel. You might be studied kernel is the heart of the operating system. I still remember in 2003 when I joined BSc degree, my computer teacher was saying kernel is the heart of the operating system. I just by hearted. I don't know what is that heart. So what is kernel? Why it is called as a heart of the operating system? The way heart is important for us to function. Similarly, the kernel is important to communicate with your hardware. So does your hardware can understand anything like Java code, .NET code, Python code, or shell script, Node.js script, whatever you have written? Does your hardware, your CPU, memory, your motherboard, will it able to understand anything? No. So kernel is a interface between what? The kernel is a interface between the software and the hardware. The kernel is interface between the software and hardware. So the kernel is going to convert human readable things into a machine understandable code. Your hardware can understand only binaries, zeros and ones. Your hardware can understand only binaries, zeros and ones. So it cannot understand any human readable code. So this kernel is responsible for communicating with hardware and software. So that OS itself we are calling as an operating system, but within the operating system, what is the major one? main important one is kernel. OS is nothing but a kernel, guys. OS is nothing but a kernel. So it is common for all the containers which is running in that system. So do we need more CPU, more memory for each container because it is going to use this system kernel? Not required. And how it is isolating? In kernel, you have some concept called namespaces and C groups. If you are from Linux background, you can understand there is a Linux namespaces. In Linux, we have a namespaces and C groups. So different namespaces like user space, process space, PID. Bhaskar sir might have explained PID, process space, network space, storage space. We call it as a mount space. Now, the Docker or any containerization software is leveraging these features of kernel for isolation. What does it mean? Even though I am running all the containers in same machine, let's say this is one of the server, this is one of the server that can be a physical machine or that can be a virtual machine. I have an operating system. I have an operating system OS. This we call it as a host operating system. Now, if I am directly deploying applications, here, is user space, network space, that process area, is it common for all these things? Because I am not isolating into a different namespaces or C groups here. If I am directly deploying like this, is this application is isolated from other if I directly deploy like this? No, because we are not leveraging the underlying the isolation concept of namespaces. Now, here in the host system, we have this concept. In the kernel, you have a user space, process space, network space, storage space, mount space. So is it common for this one and this one because I have not isolated? Is it common for this application and this application? Yes. So if this application is causing the issue, will it impact the other application? If I directly deploy like this, yes. Just to make it simple, can I have this application also running on 8080? Can I have another Tomcat? Same. Can I install one more software on 8080? Let's say, can I install Java on 8080? Can I run Jenkins also on 8080 directly if I am deploying like this? No. Why it is not possible? Why it is not possible? Is the network space also common for both? Is the network space also common for both if I do like this? Yes. So do we have a conflict of port here? Do we have a conflict of port here? Yes. And also, is it isolated from process area? Is this application is isolated from this application in the process area? No. So this is causing some issue with the Java process. And if this is also using same Java process, will it be impacted again if I directly do like this? Yes. So that's why we went for a different virtual machine. That's why we went for a different virtual machine. That's why we went for a different virtual machine. But nowadays, that is not required. In same virtual machine, using containers concept, can I isolate? Can I isolate using containers concept in the same machine? Yes. So if I am using containers, containerization software like Docker, it is just some software, but in the background, it is using the features of your kernel. This Docker software or containerization software is using features of your Linux, your kernel here. It is not doing anything rocket science here. This containerization we are using to run this application or this process in a separate area in this kernel. So when I am using containers, when I am using Docker, is this container will get its own user space, network space, process space, storage space from that underlying kernel. From the underlying kernel, this container will get its own process space, network space, storage space, and mount space. That namespaces, Linux are kernel namespaces concept. So it is going to get its own namespace. So who is creating those process space, network space, and who is making sure that this application, this process is going to run that space? That is done by this Docker. Now similarly, if this is running in a separate network space, separate storage space, separate process space, now is this possible? Can I run this software also on 8080 on its own Java process? Can I run another software also on 8080 in its own Java process? Because this is using separate process area. This is using separate process area. Kernel is same. Kernel is same. You have only one kernel in the operating system. It is nothing to do with kernel. Within that kernel, it is isolating using the namespaces and C groups concept. It is creating a separate area in that kernel. Just to make it simple, it is like wards. Suppose it is like in your hospital, right? You will have a separate wards, right? Same hospital, separate wards, like that. So which is isolated from each other. Now if something goes wrong with this process area, do we have an impact in this container, this application? No. So this is isolated this way. So isolation is happening at what level? If I am using this containerization, isolation is happening at a OS level. Isolation is happening at a OS level or software level if I am using containerization. This isolation is happening at what level if we are using hypervisor? This using hypervisor isolation is happening at what level? Is it isolating at a OS level or hardware level? Hardware level. This containerization at a OS level. Now with this understanding, with this approach, now will I able to run multiple applications in same server like this as a container? Now if I have another server where I want to deploy this application, what is the only software which is required in this machine? Only software is container, this containerization software. If I already have some package, which contains application code and softwares, will I able to quickly port that application to this server, from this server to another server? Application code with softwares, dependencies, configurations. So this way, if that application works in one server, will that container will work in another server? Yes, because we are treating that as a separate package container. If I create a package like this, application code with required softwares, can I run this package anywhere wherever I have a Docker is running? Can I run this application and the required softwares and libraries wherever my Docker is running? With this way, will I able to quickly port my application? Will I able to quickly deploy my applications? Does this application will be consistent across in any server which is running? Do you have this portability or compatibility issues? No, because is your software and configurations are getting changed, whether you are running that container in this server, whether you are running that container in other server? Is your software's configurations, libraries, application code, is it getting changed? No. So using containers, will I able to isolate our applications from underlying hardware? Yes. Which means, will I able to run anywhere these containers wherever I have a Docker installed? That can be your local laptop where your Docker is installed. That can be your cloud server where you have a Docker installed. That can be your data center server where you have Docker installed. Can I run this application wherever I have a Docker? Yes. So this is how containerization evolved. So from 2013 or majorly from 2015, 2013 is just started, but from 2015 people started using this containers concept like anything. Now whatever applications, whatever projects are being developed recently, most of the projects are they directly deploying the way we deployed so far till yesterday. We deployed in a different way. From today onwards, we are going to deploy in a different way. So the recent projects, most of them are deploying as a containers. In AWS, what in AWS I deployed a lot of applications in the EC2 instances. In which model? That is falls under which one? Is it a traditional deployment? Is it a virtualized deployment? Or is it a container deployment? In AWS. In AWS servers we created. Is it a container deployment? People are saying it's a container deployment. Is it a container deployment? No ways. Where did I create containers? It's a virtualized deployment. So that EC2 instance is nothing but a virtual machine. Did I directly install required softwares on that virtual machine like Java software, Tomcat software, and did I deploy that application directly in the server? This I deployed in one server. The one more application, the Maven web application, did I deploy a separate virtual machine? Did I install required softwares and libraries for that? Did I deploy that Maven web application in a separate server? Did I deploy Java web application in a separate server? Now, can I deploy these two applications as a containers in a single server using containerization concept now? So in that case, do I need a two separate virtual machines with two separate operating systems? Not required. So that is what? Containerization. This is very, very important. This is very, very important. If you understand what we discussed today, you can understand most of the things. Why Docker? Why containers? Is everyone clear? Just a single slide I have explained whole day. Without explaining this, if I directly go for a containers, you will not understand why I am creating containers, why I am using containers, why I am using Docker. You will not understand if I directly go to the Docker. I have not yet started anything related to Docker. In the interview also they'll ask difference between virtualization and containerization. One of the important interview question also. If you observe, what is the difference between virtualization and containerization, or difference between virtual machines or containers? So virtual machine, will it be heavyweight? Will it be heavyweight? Why it is heavyweight? Because each virtual machine will have its own operating system. Does it require some CPU memory? So virtualization is happening at what level? Here, hardware level virtualization in the virtual machine. So does virtual machine will take some time to start? I mean to say to boot up. And one more important problem here, do I need to configure that virtual machine with required softwares and libraries to run my application before doing that? Yes. Now each machine will have its own operating system. It will allocate required memory, right? Now when it comes to containers are lightweight. Why it is lightweight? Does containers will have a full-blown operating system? Does containers will have a complete operating system or full-blown operating system? No. So will I have a better performance? Since It doesn't have full-blown operating system. It is only application process. Will get a better performance. All containers, what is common for all the containers? The underlying host operating system. So this isolation is happening at what level? OS level. If I am using containers, does containers can be started within max, fraction of seconds? Can we start our containers within a fraction of seconds? Yes. Does containers will take less memory space, less memory, less RAM? Because it is not have operating system. So it is like a process level isolation. Process level isolation. Process level. Each process is isolated from other, which means does each container is nothing but some process is running in that one. Does each process or each container is isolated from other even though they are running in the same machine? Yes. Now this this is also important comparison. So I am not that much creative. I just took this diagram from some website. I am not that much creative. I just took this diagram from some website. So size, virtual machine size, it is like an elephant, very huge in size, which means the size of the ISO file. What is ISO file? In the AWS, it is like a AMI. In AWS, it is like a AMI. So the size of the VM image, kind of a AMI, it will be very huge. But when it comes to Docker image, the size is very less. It will be in hardly in MBs, hardly in MBs, and it will take very less resources, whereas VM take more resources. Startup, it is like a tortoise. VM startup is like a tortoise. Does VM will take some time to start? It will take some time to boot the operating system and start. Now, this startup, like container startup is like cheap. What does it mean? Will I able to quickly spin up my containers? Will I able to quickly start my containers, my applications as a container? Very fast. And integration also smooth when it is containers. It is little difficult when it comes to virtualization. So interviews also they are asking this question. So I'm just explaining this one. Don't say VM is elephant, Docker is rat, VM is tortoise, Docker is cheat. Don't say like that. So size is very huge. Size is very huge. Size is very less. Startup will be very fast. Startup will be very less. Don't say VM is an elephant like that. So this is just a comparison. Okay. Is everyone clear? Difference between virtualization and containerization? Why containers? With that background, tomorrow I am going to start actual Docker. Today I have not at all started Docker. With that background, tomorrow I am going to start actual Docker. What is Docker? How to install Docker? How to create images? How to create containers? From tomorrow onwards, we will discuss. Guys, this Dockers and Kubernetes, we are covering like anything. In and out of Dockers and Kubernetes, we are going to cover. That's why I need maybe another 14 to 15 days to discuss Docker. Another 14 to 15 days to discuss Docker. The Kubernetes itself required 22 to 24 days, anytime between these many days. You can imagine how many days of classes are left. Approximately 38 to 40 days of classes are left. Another 2 weeks, another 2 months. Sir, in containerization, hardware is common. Without hardware, will you have a OS, Dada Saheb? No. So hardware is also common. Without this, will you able to have this? Can I take this away? Without this, Can I have this? No. With this, I have this, which means for all these things, the hardware is also common. Okay, guys, that's it for today. We'll try to discuss in and out of all these things, but I need a dedication, commitment from you so that you can become expert. You can clear CKA exam also. That much level we are covering. Certified Kubernetes Administrator certification also you can do. Lot of our students has done that CKA just by attending these classes itself. That much extent we are covering, but you need to attend, you need to practice. More dedication, more commitment, more hands-on is required. But if you just attend for the sake of attending, you cannot clear. Okay. Yes, anyone can appear, but you need to do lot of practice, lot of hands-on is required. CKA is not like a multiple choice question. They will not give question and they will give some options like that. They will give one scenario, task based. They will give one scenario. You need to implement the task. If you don't done lot of practice, if you have not attended all the sessions, if you have not done the practice, you cannot complete the task. It is not like a radio button or a check boxes kind of is, multiple choice question. It is task based question. But if you do lot of practice and attended all the sessions, you can easily crack. Lot of students cracked, our students cracked CKA. How much price to pay for CKA? I think, let me, last time when I checked, it was like somewhere around 14,000, I believe. Let me show you. CNCF, Cloud Native Computing Foundation, certification, CKA, Certified Kubernetes Administrator, $375 for that certification. But not from here, guys. Not from here. Some other websites also there, like Linux Foundation. Sometimes they give offers also. Sometimes like they will give offers also. So sometimes you'll get only for 15,000, 13,000 also like that. Sometimes they'll give the offers also. So this is the weightage in that area. This much concepts come from, this much percentage of questions come from this. All these concepts we are going to cover. But if you don't practice, it won't help you. Thank you, guys. I'll continue tomorrow with actual Docker. So don't miss any session. As I already told, even though it is difficult, don't give up. Try to go through the recordings multiple times. Do the practice. You can become an expert. Don't give up saying that it is very difficult. If you give up, it will be like never ending story. Like March to September, September to March, same story. Thank you, guys. I'll continue tomorrow.